The biggest space telescope, the time machine that lets us see the 13.8 billion years back in time. Yes, I am talking about James Webb Space Telescope. On December 22, 2021, a team of NASA with the collaboration of European Space Agency and the Canadian Space Agency will going to put the James Webb Telescope in space with the rocket Ariane 5 ECA from French Guiana. This space telescope will act as a third eye or time machine that will unfold lots of mysteries related to the past of our universe, like how the first galaxy was formed in our universe, by observing them. Webb will journey to a distant destination about 1 million miles that are 1.6 kilometers from Earth, known as Lagrange Point 2. It is the point where gravity from the Sun and Earth balance the orbital motion of the James Webb Space Telescope. The telescope will spend its first month after launch getting to this point and unfolding its sun shield and mirrors. The sun shield will face the Earth and the Moon and the Sun all the time, keeping light and heat away from telescope-sensitive instrument. Once at L2, the telescope will spend another 5 months turning on and testing its scientific instrument before collecting data. Development of this telescope began in 1996 and planned for launch in 2007 with a budget of $500 million, but got several delays and underwent a major redesign in 2005. Finally, its construction was completed in late 2016. In March 2018, its sun shield ripped during a practice deployment, and then due to the COVID-19 pandemic it got more delayed. Initially, the launch was October 31, 2021, but due to the problems with the Ariane 5 launch vehicle, launch date was pushed to December 18, 2021. Again, due to a problem with the sudden, unplanned release of a clamp band, which caused a vibration throughout the observatory, it finally planned to launch on no longer before December 22, 2021 with a final budget of $9.8 billion. Webb telescope looks at the universe in the infrared part of the electromagnetic spectrum within the wavelength of 0.6 to 28 microns. Whereas the infrared part of the electromagnetic spectrum goes from about 0.75 microns to a few hundred microns. So, it will work primarily in the infrared range of the electromagnetic spectrum with some visible range, particularly in red and up to yellow parts of the electromagnetic spectrum. It is supposed to be a successor of the Hubble telescope, as it will provide improved infrared resolution and sensitivity over the Hubble Space Telescope. Comparison of the Carina Nebula, in visible light, left, and infrared, right, both images by Hubble. In the infrared image, we can see more stars than weren't visible before. Diameter of the primary mirror of the Webb is 6.5 meters, whereas the diameter of Hubble is just 2.4 meters. The collecting area of 24.5 meters square, which is around 6.25 times more collecting area than Hubble, using 18 hexagonal mirrors with 0.9 meters square. To make an observation in infrared, it is necessary to keep the telescope at a very low temperature, under 50 K, otherwise, the infrared radiation from the telescope itself decreased the sensitivity of its instrument. It, therefore, uses a large sun shield which the radiation from the Sun, the Earth, and the Moon. Its position at the L2 will keep this three-body at the same side all the time. As the Earth orbit the Sun, Webb will orbit with it, but stay fixed in the same spot with relation to the Earth and the Sun as shown in the figure. Actually, Webb will orbit around L2 point. So this all, for now. We will see in the next video what are the main goals of this telescope and how it will change the face of astronomy for all time. Till then, have good luck and do subscribe to this channel for more stuff like this. Thank you.